Good morning, good afternoon, or good evening, depending on where you're joining our live broadcast from today. My name is Tony Beeston, and I'm hosting your event. Briefly, some housekeeping. We are on a public webinar, so your phone lines will remain on mute. Please use the question area in BrightTalk to raise any questions you have from today's presentation, and the speakers and myself will go through these at the end. This webinar is being recorded and will be available to you through the same link you joined with today. So if you want to review over the coming weeks or share with others, you can. Now, with that done, I'd like to introduce you to our speakers today. Unfortunately, Dan was unable to join us, but we still have the product experts from Terma, both Jennifer Chiswick and Shane Hayde. So they're going to be able to take us through what it's all about, to what you can change for IT operations and for the business with this technology. So please sit down, sit back, relax, and see how you can improve your service delivery for AutoSys. Dan, have you just joined us by any chance?
Yes.
So Dan, I would like to give the floor to yourself.
All right. Thank you. So my name is Dan Shannon. I'm the Senior Product Line Manager responsible for AutoSys and some of the other technologies within the Broadcom automation segment. And today I'm very pleased to be able to share some news of an exciting new addition to the Broadcom automation portfolio. Termlabs is now a part of Broadcom. The popular JAWS product is used by many of the AutoSys and CA7 customers to proactively manage their SLAs. So why is this so exciting if the product already supports AutoSys? Well, there are a number of reasons. By joining forces, we'll be able to deliver new functionality that could only be developed through close collaboration, making the product more robust and easier to use. By providing a single vendor solution, we can deliver same-day support for new releases of the workload automation engines. And by combining the Broadcom resources, the Terma intellectual property and talent, we believe we can make significant advancements to our solutions, which customers will love. So without further ado, let me turn this over to Shane and Jennifer, and they'll tell you more about it. Thank you.
Great. Thank you very much, Dan. Good morning, afternoon, everybody. This is Shane Hayde, former CEO of Terma Software. I'll be presenting along with Jennifer Chiswick today. Jennifer Chiswick was the Termlabs CTO, and she's also a founder of the organization. So we're going to start with a little bit of background on the company. All right, thank you. So Termlabs is the premier analytics solution for workload in the market. We are the only solution in the market which actually provides for a single pane of glass, spanning multiple vendor products, which will allow for visualization of dependencies across these products. It also allows for visualization of single products environments so that you can optimize and manage them much more effectively. Our client footprint is primarily in the Fortune 500 with a very large install base in the financial services sector. Jennifer, is there anything you'd like to add on some of the history of how we came to be with AutoSys?
Sure, I can add a little color there. First, I'd like to just say welcome to everyone, and I'm so happy to be here and to be part of the Broadcom team. The Terma Analytics platform is now going to be called the Atomic Automation Intelligence, or Atomic AI is going to be the new name for the product. We haven't updated the slides yet, but that's the evolution. We started, going through the history as Shane began. In the early 2000s, we started down this road of predictive analytics and SLA management and critical path analysis, all the features that we do. It came as an outgrowth of some work that I had been doing for another company called Folded Space, where we had built some visualization tools that allowed you to visualize and model the AutoSys job streams, basically. And we realized that there was a real need in the marketplace for predictions, simulations, SLA management, and after that company was acquired, we started on this venture. So it's been a journey, and for this particular audience, you know, the first scheduler that we supported was AutoSys. So we have quite a lot of AutoSys expertise, and it's probably the most depth expertise that we have. So it's quite mature for that audience. So we're looking forward to showing it to you, and if you haven't seen it before, getting you a demo, etc. And I'll hand it back to you, Shane.
Great. Thank you. Sorry, I thought we had the scheduler slide in front of us. I did just want to point out that, as I had mentioned, our install base is very synergistic with Broadcom's. We have focused on large institutions. Of course, that's not solely what our client base is, but because of the overlap that we have with the large institutions, as you can see here, like the State Street, Morgan Stanley, Wells Fargo, it was very synergistic with Broadcom, which made it a very attractive collaboration, leading us to them acquiring our firm. We did want to talk just a little bit about the schedulers that we support. Of course, this is a AutoSys-focused discussion today, but I'm sure that many of the organizations that are in today's webinar also have other solutions. So currently with Broadcom, we're supporting AutoSys, CA7, and JobTrack. We also support IBM's Mainframe and Distributed solution, IWSZ and IWSD, as well as Title. So when we're talking through some of the use cases today, we'll actually have examples of multi-scheduler environments where we have our single pane of glass with an integrated view combining these platforms. So let's talk a little bit about some of the benefits that we can bring to your organization. As Jennifer had mentioned, our primary use case was really around SLA management. And this SLA management includes both a single platform SLA management, where from a single view, you can manage multiple SLAs in a complex environment, as well as across platforms if you have multiple platforms and have implemented the product in that way. Something else that we really find our clients benefiting from is the alert management. So we have a smart alert platform. So rather than having a flood of alerts that has to be dealt with by operations, you can manage by exception, focusing just on the key alerts that will actually have an impact on a particular SLA. Also, something that is very critical to our user base is the predictive capabilities, and this predictive capabilities actually will tell you what the impacts of either slowdowns or outages are to an SLA. So if you have an event at 8 p.m. in the evening that affects an SLA, it's 2 a.m., we actually will predict what that effect will be, and can additionally provide a what-if capability so that if you think that your outage will be, say, for an hour, you can input that as a completion time, and we can repredict and tell you when the SLA should be completed by. We also have full dashboarding and reporting, and this allows for self-service capabilities. Many of our clients use this so that they can reduce the overhead on their core workload teams and give benefits directly to business end users to be able to get that information they need to make their critical business decisions. Great. A couple of other things. Again, we have a very workload-specific reporting package. And we also have the capability of allowing for an organization to manage their workloads from a business perspective. So rather than necessarily using the dependencies which are defined within the schedulers themselves, you can actually see this in terms of how will it affect a particular business and define the dependencies around a particular business. Jennifer, is there anything else you'd like to add on the benefits?
No, Shane, I think, we have slides that go into more detail on these points, so I'll hold off comments until you get to the next slide.
Great, thank you. All right, so we're just going to take a quick overview of the components of the platform. Then we're going to look at some use cases, and I also wanted to add that Jennifer is going to be providing a demo of the actual product towards the end. But we wanted to give you some context, so we're going to show you what the components are. So what you're seeing now is the SLA Management and Predictions capabilities. This was the original flagship product that the business was built around. I'm sure some of you know of this product, and it's called JAWS. And even though it's gone through a few permutations of naming in its lifetime, it looks like JAWS is going to stick as at least a colloquial acronym for the product. As I had said earlier, we have customizable dashboards. This can be customized by individual, by groups. You can share these dashboards if you like. And all of these dashboards are actually available as a microservice as well, so that they can be embedded in another application. So if you don't, as an organization, want to have another application on your desktop, and you have a portal through which your users interface with your various systems, these dashboards can essentially be plugged into that portal. And as I had said, we have a very robust business intelligence and reporting capability, very specific to workload. So we have taken all of our knowledge that we have from workload and created a base set of capabilities to make it easy for you to get reporting, advanced reporting, up and running quickly. The reports can be output to any format you need. They can be scheduled. You can create a base set of reports that could then be modified by users. So everything that you would expect in an advanced reporting solution can be found in our platform. Now this is a newer capability that we have, which we're calling the application landscape. And this is essentially a higher level view of your batch environment aggregated at a business level. So again, rather than looking at detailed individual jobs, you can aggregate these jobs into something that, say, would affect a particular business area. And this allows for a much easier way to monitor and visualize your batch from a business perspective, so that you can essentially monitor these large complex environments much more easily and provide intelligence to the business users. Jennifer, is there anything you'd like to add on this slide?
Sure, yeah. So this is an exciting new area that we're planning on evolving, this application landscape concept. I mean, we've always had a focus on aligning workload with the business. It's always been an issue that these large workload environments, an AutoSys instance might be running, your AutoSys might be running 60,000 jobs a day, 80,000 jobs a day, even 20,000 jobs a day, is a lot. And the job names, as you know, are cryptic and not that user-friendly for the business user. So one of our goals from the very beginning has been to allow you to align those processes with lines of business. And as you'll see in the demo, that's something that we do and have done for a long time, where you can create job streams and align them with lines of business. That particular usage, which is quite valuable, is based upon job dependencies. So if a particular job is indicated to be like an SLA within, call it the finance organization, we will detect all of, automatically discover all of the upstream predecessor jobs to that job and put it into the finance business area. So this is an evolution of that, which will allow you to create a business application, which is not necessarily constrained by dependencies. So you may have a pricing application which is comprised of jobs that are not related by dependencies, and it begins with potentially the completion of maybe a job in your distributed AutoSys environment as well as a job in your mainframe environment. Maybe both of those jobs together, having completed, would define the beginning of a business application starting. And similarly, you may have unrelated jobs that represent the end of the business application. So through application landscape, you can model that business process, and then that business process, when complete, may represent the beginning of a subsequent business process. So you can model the entire landscape and monitor it, put SLAs on it, and alert against it, really elevating the workload out of operations and into the line of business. So it's something we're really excited about, and will be evolving under Broadcom.
Great. Thank you, Jennifer. I did see a couple of questions pop up on the screen around reporting. One was around trend analysis, and the other was how much history do we have. Why don't we add...
Sorry, Shane, to interrupt you. We'll cover questions at the end, if you don't mind.
Yes, of course. Yes, of course. That's exactly what I was getting to. So we can actually have that towards the end, and these will actually both be answered within the demo that Jennifer will give. Thank you, Tony. Okay, so moving along, another one of our newer offerings is around Workload Devops, and this is essentially a modeling and simulation capability which can allow for you to see the impact of changes to your production batch prior to your actually implementing those. So this is one of Jennifer's star accomplishments in designing and creating the solution. Jennifer, would you like to add more to this?
Sure, and I think we do have another slide about this, but in general, the concept here, this is a new concept that we're introducing, which allows you to input proposed JIL changes into the platform, and we will simulate what those changes would do on your critical SLAs, and if the proposed changes would breach any SLAs or anything like that. So we do have another area where we're going to discuss this, but that's the general concept here.
Great. Thank you, Jennifer. Now, the last capability in the platform we like to example is our API. Through the API, you can actually gain access to all of the information and all of the capabilities that we have exampled in the previous slides. You can actually set SLAs. You can set alerts. You can subscribe to alerts. You can subscribe to any of the information that is within the system. You could actually gain access to all of the reporting as well. And what this allows for is the solution to act as a black box workload intelligence engine that sits behind your corporate information systems and provides all of the capabilities that the platform can without the users necessarily having to interact. Some of our larger clients use this, again, because they're not looking to place yet again another application on their users' desktops, but they want all of our intelligence, the predictions, the what-ifs, the aggregation of information across the multiple schedulers. So this is a very, very powerful and ever-evolving capability, which we'll example some in the use cases. So with that, we're going to move forward and start talking about some specific use cases which are built around client success stories. So what we're going to start with is an implementation at State Street Bank. State Street is an AutoSys and IWS Z environment, and their primary use case was to have visibility across their scheduling environments. So they have job streams that start in AutoSys, end in end in IWS Z. That's IWS on the mainframe. Some of theirs actually start in AutoSys, go to IWS Z, and then back to AutoSys. Prior to implementing our solution, they had no visibility if there was an outage as to what the downstream impacts would be. So with the implementation of our product, they have full visualization of all of the data, all of the job streams across the platform. So if they have something that starts in AutoSys, ends in IWS-Z, if there's an outage in AutoSys, we actually predict what the impact on the mainframe platform is. This gave an unprecedented level of visibility to outage effects to their management and allowing them to manage their environment much more effectively. Another use case with State Street is what we call a black box application. I'm sure many of you have in your AutoSys environments applications that are logically part of your work stream, but aren't necessarily part of an AutoSys. So if you have, say, an ERP system that an AutoSys job kicks off a set of processes in the ERP system, and then it goes and does its thing, and then branches back into AutoSys, you have no visibility of what happens in that ERP. It's just a black hole. Through our API, you can actually create application components that feed information in, and you can then see and visualize what the effects of, say, in this example, the ERP system would be. This is something that is being implemented at State Street, and again, it provides for a unprecedented level of understanding into the full dependency tree of your batch, whereas before you had no visibility into these external applications. Jennifer, is there anything you would like to add on that one?
Yeah, I mean, both of these cases really are taking advantage of a concept that we refer to as cross-scheduler dependencies that we've introduced into the platform that allows for the modeling of dependencies between two unrelated schedulers or unrelated external processes. So, you know, in the first case between IWS-Z and AutoSys, you know, the fact is that those two schedulers don't actually directly talk to one another. There's no syntax where you can suggest that an IWS job would start an AutoSys job. But through our use of the cross-scheduler dependencies, what we're creating is a link that can be used for the purposes of monitoring and analytics. It doesn't actually execute in the scheduling environment, but it models what is the reality. So the reality might be, and in the case of the use case that we just talked about, the reality was that an IWS-Z mainframe job, and this could just as easily be a CA7 mainframe job, would through its processing trigger a global variable in AutoSys, and that global variable would then start a job. So it was an indirect relationship between the two schedulers. So that's, you know, one of the keys to the platform as a whole is that we can model those types of external dependencies and bring them into an overall picture. So you really can gain visibility, track the critical path, and have the benefit of seeing the downstream impacts. So you might have a job on the mainframe that abends, and that's going to trigger an alert within our platform. It will trigger an alert that maybe your AutoSys job is not predicted to run or something like that. So you get visibility across platforms. Just wanted to kind of highlight that a little bit. And then back to you, Shane.
Great, thank you, Jennifer. So another use case we wanted to example was the use of our platform as a back-end black box intelligence engine. And this is what I had spoken to earlier, where through our API, you can use the platform to integrate the information that we produce, consume, and create into other existing corporate platforms. Morgan Stanley is our preeminent implementation of this model, where they're essentially using us as an aggregation point for a multitude of schedulers that they have in their environment, spanning both distributed and mainframe environments. Moving to an example of the simulation and modeling, I'll turn this over to Jennifer. She went into it a little bit before, but we'll talk about it in the context of a specific client use case. Jennifer?
Okay, great. Yeah, so the simulation and modeling, which I had mentioned before, is a way for you to simulate proposed changes to your batch without actually implementing them in a scheduler. So this diagram on the screen shows you a simplistic view of how it works. The Terma Analytics platform already has all of the information about your production AutoSys jobs. It knows what all of the dependencies are, and calendar conditions, etc. We're already predicting your production batch. So what we do in the simulation and modeling is we allow you to input a GIL file that has proposed modifications to your production environment. So you may be implementing a new accounting system, and in that system you have a GIL file that will represent 100 new jobs as well as 50 dependency changes, and you're also going to delete a dozen unnecessary jobs as part of that. So you have a rather complex GIL file. You can read that file into our platform. We'll combine that with all of the production job definitions and run a simulation. And after that, you'll be able to see if the proposed GIL that you are planning on is going to break any of your existing SLAs. One other key component to that is when you load in the GIL, you can annotate any new jobs that you're proposing with the anticipated duration of that job, because that's important to model how long you think those jobs are going to run, because since we have no history, we wouldn't be able to guess how long the jobs will run for. But through your clues about that, we'll feed that into the model and determine if any SLAs will be breached. And this, in combination with the REST API, we're working towards getting this to a place where it can all be invoked via an API, via our REST API. So you could make it part of your CI/CD stream for promoting GIL. Is like a process prior to promoting it is validating that, simulating it and validating that no SLAs are breached. So it's an exciting area. We're starting with AutoSys. So for this group, you get the benefit of that, and we will be adding support for other schedulers as well.
Great, thank you, Jennifer. So another critical use case that our product is used for is for batch optimization, and this is essentially for optimizing how your batch runs, how you have your batch designed so that you can reduce your batch windows. We've had numerous clients use this that without making really significant changes to their batch have reduced their batch windows by 20, 30%. And as you can imagine, as these systems grow in complexity over time, because certainly none of them are getting any simpler, we're always running up against hitting our batch windows. So organizations are looking at how can they optimize their batch window without necessarily throwing more hardware at the problem or agents at the problem. How do you do it through a design perspective rather than from an underlying environmental engineering perspective? Jennifer, would you like to add some more to this?
Yeah, just, there's a lot that we do in this area of optimization and providing analytics that make it easier for you to optimize your batch. One of the things that we do, I mean, there's a lot, it basically all falls into the category of critical path analysis, because we have a great capacity to identify your critical path through your batch. And that really is the key to optimization, because if you want to optimize your batch, you need to understand where the bottlenecks are across the critical path. So the first part of optimization is really studying the critical path and seeing how it can change from day to day. And then the next pieces of optimizing, some of the things that we can highlight through our analytics are things like uncovering places where your critical path is being affected because of some load balancing conditions that you have in place. So in AutoSys, you may have a machine where you have a max load defined, and that max load gets exceeded, and so certain jobs can't run because they're waiting for that resource to free up. So that is one of the types of analytics that we offer, is to identify that and show you where you have this resource wait time. You're basically waiting for a resource to free up. So that's just one example. There's other examples of how your critical path can be impacted by various factors. So in addition to, I guess the main point to highlight is that in addition to the monitoring and predictive capabilities of the product, it's also very useful for batch optimization through analyzing historical data.
Great. Thank you very much, Jennifer. So another use case that we'll talk about here is for Union Bank, a recent client success story for Terma software. And this is a single pane of glass across multiple schedulers, actually 3 schedulers. It's AutoSys CA7 and Title. And within this scenario, they can see and visualize their entire environment across all of these schedulers in this single pane of glass. This provides for consolidated reporting across all of the schedulers, dashboards for the schedulers that they can then push out to their business end users, as well as, again, predictions across all of the schedulers and dependencies across the schedulers as well. So, again, of course, this is an AutoSys-specific discussion we're having today, but we're aware that many of your environments encompass more than just AutoSys, and so the capabilities that we bring to AutoSys can be extended to your entire organization. Great. So with this, we're going to move into a demonstration of the platform, which will be moderated by Jennifer. Jennifer, do you want to go? Are you prepared to go ahead and share your screen? Here we go.
Great. Thanks so much, Shane. Okay, so I'm going to give you the briefest of demonstrations. To really go through a full demonstration of the product would take some significant time. I just wanted to highlight a few areas for you, and we can always follow up with more detailed demonstrations. What you're looking at here is the main client of the for the SLA Management critical path analysis portion of the product, and we also have a thin client available. This is a Java this is a Java application, and we also do have a thin client user interface available. For today, I'm just going to start with this thick client and show you some of the features and functions. So the first thing I wanted to just kind of show you is that this whole user interface is geared around business areas. So you kind of start by setting up your lines of business. And in this demo environment that I'm showing you, we've set it up as if we were a financial services organization. So the types of business areas you might see are equities, finance, online trading, etc. And then within the business areas, you have certain job streams or business applications that are running. So you can organize them by business area or line of business. And you can create, you can actually cross-pollinate. So you can have a business process like this one we're looking at right now, which is process trades end-to-end. You can have that as part of the finance line of business, but you might also want that to be part of North America. So you can put them in multiple lines of business. So we have the ability to categorize those. And what you're looking at on the screen here is this analysis tab, which is specifically for historical analytics. This is to show you a post-mortem analysis of how your batch actually ran. The dashboard and the monitoring tabs are available to show you, to monitor what's currently running and what's predicted to run in the future. So these two tabs are more related to operations, monitoring and prediction, and the analysis tab is for historical analytics. This demo environment happens to have multiple instances of schedulers added to it. So it has a couple of AutoSys instances, it has a CA7 instance, it has an IWSZ instance, all of them in this single pane of glass that we're looking at here. This particular process trades end-to-end job stream is one that we've created that goes from AutoSys to CA7. So I just wanted to show you how that works a little bit and just use a few minutes in this demo to walk you through this particular use case. Of course, there's a whole host of other features and reports and various analytics available, but in this short amount of time I just wanted to give you a flavor for what we're looking at. So what you'll see here is this is a, like I mentioned, it's an AutoSys to CA7 application. So you've got here an AutoSys box, and if I open it up, it has a handful of jobs in it. What happens here is that the last job in AutoSys that runs, and this right now, just to give you context, we're looking at a run that happened yesterday at 6 p.m. So it's December 11th at 6 p.m. You can drop down this calendar and we can take a look at the run for this job stream on any day that we have history for, and you can see exactly how it ran on that particular day. So we're looking at a particular instance. And if I right-click on a job and look at its details, you'll be able to see all of the, in this case it's an AutoSys job, so you see all of the AutoSys JIL properties for that job. You can see that this particular one has start times, various start times during the day. It's got various other JIL properties. And it has a command where that command is executing a batch file that's called sendFile.bat. So what's really happening is that job is sending a file to CA7, and it shows up in CA7 as a data set. So you'll see this is the data set that gets created on the mainframe. And that data set in turn triggers the subsequent CA7 workflow, ultimately culminating in this one target job. You'll see there's this one job that has a target on it. And this job might have an SLA that it has to finish by a certain time. So we're now tracing it from AutoSys through the dataset trigger and into CA7. And this is showing you historically how it ran. I'm going to quickly move over to the monitoring tab, and I'm going to show you that this is actually currently running. And you'll see the process trades end-to-end row in this table that it started at 6 a.m. Pacific time this morning, and it's predicted to end at 9:15 a.m. I happen to be in Pacific time, and it's currently 8:39 where I am, so this is predicted to end in about 40 minutes. It's 80% complete, and it's predicted to be late. So at this point you would be getting, potentially you would be seeing late alerts if you have alerting enabled. We didn't really get into how to configure alerting, but if alerting was enabled, alerts would be generated because this is predicted to miss its SLA. And from this point, you can drill in and click on the real-time Gantt chart, and now what you'll see here is a Gantt chart which is similar to the ones we were looking at in analysis, except this is real-time. So this solid line down the middle of the screen is right now, and it will continue to move forward in time as time progresses. And everything to the left of the line is an actual, so we can see exactly when the job started and finished. And now we'll show you predictions for when all of the jobs that have not yet run, and these happen to be on CA7, will start and end. And as the jobs are executing and predictions are being replaced by actuals, we will adjust the predictions. So we might have predicted that a job would run for 20 minutes, but in fact it ran for 15 minutes. Well, at that point, we will notice that it only ran for 15 minutes, so we will re-predict everything downstream and then accordingly predict that your target job will complete sooner. So, so that's just a really brief kind of tour of some of the highlights of the predictive capabilities of the product, and just to give you a flavor of it. Like I mentioned, we can't get into too much detail in this amount of time, so I just wanted to give you a flavor, and then I will I'll turn it back over to you, Tony, to take questions and see if there's any follow-up.
Thank you very much indeed, Jennifer, for going through that. We've switched to the question screen, so you still have time, audience. If you have a question, please remember to type it in at the bottom of the screen where you can see ask a question, and we will get to it. We do have a couple of questions already. I think they're probably directed more at Jennifer, but please, whoever's going to answer, please jump in first. The first question is, can you talk a little bit more about the reporting? How much history do you have? What types of reports are available?
Yes, absolutely. So we have as part of our architecture, we have a data warehouse where we retain as much history as you would like. So most of our installations, clients are keeping over a year's worth of historical data. So that means every run of every job in every scheduler that's defined for a year. So that's a wealth of information that we can then report on. We use information for analytics. We have a statistics generator that will look at all of that wealth of data and find average durations for the jobs by day and all kinds of other statistics that we're calculating based upon looking at that historical data. But it's also available to report on, and we have many reports available. You can do SLA reports to see how the job streams in a particular business area have performed over time. How often did they make or miss their SLA? We have scheduling load reports that will show you how much load has been put on the scheduler over time, machine usage reports, various, a whole host of reports, and also the ability for you to create your own custom reports that take advantage of this data warehouse. So, so that's a big topic, and we could demo the reports for an hour alone. So maybe someday we'll do that.
Thank you very much for that, Jennifer. The next question you have is, I'm wondering what type of trend analysis can be done with the product.
Sure. So the statistics generator that I was just referring to, in addition to calculating averages, it also calculates trends. So you can get a trend. You can get multiple trends for every single job in your environment. So we can do a 30-day trend, a 90-day trend, a year-long trend for every single job in your environment, and it actually gets recalculated every night as part of the statistics generator. So through this, and it's quite, calculating trends is a quite computationally expensive operation. So that's why we do it once a night, and then we save the trends in the database so that they're easy to retrieve. So through these pre-calculated trends, we can answer the question like, can you tell me which jobs in a particular business area are trending longer over time? And we will surface those jobs. And what you might learn from that is that a certain job has been trending longer to the point where it is now part of the critical path of your business application. So we do quite a lot with trend analysis to help you anticipate potential creeping problems before they occur. So if you can detect a trend that's happening, you can get ahead of it before it becomes a critical issue.
Excellent.
Okay, Tony,
thank you very much. Nope, that's perfect. The next question I'll actually be answering on behalf, because I already know the answer to it. So somebody has asked the question, will JAWS be integrating with iDash, or is that something that's slated afterwards? All of our engineering teams are all getting together and chatting. There is a roadmap presentation that they're putting together that we will be pushing out to invite you to. The hope was to do that within December. I think more realistically, because of Christmas, that is likely to occur very, very, very early in the new year. So look out for that invitation that you will definitely receive, because we'll send it to the same people. But iDash, for those that you don't know, is a product that connects into CA7 and AutoSys, and it provides some of the functionality that we've been talking about here. iDash is continuing forward as it normally was. So all of the things that the development were working on, they're still working on, still producing and still taking out there. But there will obviously be conversations across the teams about how can we propagate and benefit from this. So I took that one on behalf of the team. That seems to be our last question. So first of all, I'd like to thank Dan, Shane, and Jennifer for presenting how to improve SLA delivery in AutoSys. I hope you, the audience, have found it useful. If you need any further information, you want to ask other questions about what's going on, please, obviously, in the first instance, reach out to your account team. They're there. However, if you want to ask somebody more directly, you can see on this screen we've got Dan's email address. As always, he loves to hear from the AutoSys customers and what's going on. You can also ask myself, and I will connect and direct your question to the right place. So thank you all for attending, and enjoy the rest of your day.